So at this point, what I want to do is I want to do the integration by parts tricks, and I want to do 3 integrals, and a few of them don't necessarily look like integration by parts problems exactly. But what I want to do is I want to look at sine squared of x. I want to evaluate the natural log of x, and I want to evaluate sine of x times e to the x. Okay, and I might put constants in here. The natural log is not super relevant here what the constant is, but for the sine squared and the other one, I might put constants in here. Sine squared, there's actually 2 ways to do this, and we'll talk about that. We'll talk about that in a second, but this kind of integral is what will lead us to section 7.2 and 7.3, which is all about integrating trig functions. Okay, so we'll get into things like this in a second. Let's start with sine squared. Okay, so let's evaluate sine squared. Now, one thing that we can do just to notice is that this is 1 minus cosine squared, but that doesn't actually help us, right? That doesn't really give us any advantage in evaluating this. So there's no point in rewriting it that way. And so what we're going to do is we're going to apply integration by parts in a kind of clever way. So I'm going to let f prime in G both be sine of x. So we get sine of x here and sine of x here. And then f in G prime. So f is going to be, let's see, if f prime is sine, then f is negative cosine. And if g is sine, then g prime is cosine, positive cosine. And so what's going to happen is that our integral is going to become f times g. So that's negative sine x cosine x minus the integral of f times g prime. So that's negative cosine of x times another cosine of x dx. And if we were to just do integration by parts again, what would happen is that this process would undo itself and we'd end up with the integral of sine squared x equals the integral of sine squared x, which is true but not helpful, right? That doesn't tell us what the integral is, just that it's equal to itself. What we can do though is we can evaluate cosine squared and think of this as 1 minus sine squared, like we were just saying. Now it does help. So what we're going to do is I'm going to, in the integral, think of this as 1 minus sine squared x. And so think about what just happened here. Actually, before I rewrite this, let's just evaluate. This is negative sine x cosine x plus the integral of 1 minus the integral of sine squared x. Okay, this x here came from thinking of this as the integral of 1 dx, and then the integral of 1 is just x. Now think about what just happened here. The integral of sine squared, we just wrote in terms of itself. And so let's call this I. So I'm going to define this. I'm going to call this I. So what we just said is that I, this integral that we're looking to evaluate, is x minus sine x cosine x minus I. And what is, how do we solve for I? We're just going to add I to both sides. That'll give us 2I. So 2I is equal to x minus sine x cosine x. And then we can divide by 2. So I is going to be 1/2 of x minus sine x cosine x. And then of course this is a indefinite integral, so we need a plus c. I could have had a plus c at any point. Here we had an integral on both sides, so probably when we had the integral by itself, I should put in a plus c. Okay, but that's it. So that's one way to do this problem, and we'll talk about another way to do it in the next section. But this is an integration by parts, even if it doesn't quite look it. Okay, it's a little bit of a trick where you define the integral, you write it in terms of itself, and then you can solve for the integral and everything is fine. Okay, and so that's the first one to do. All right, the next one to do is I want to integrate. So I want to integrate the natural log of x. Okay, and what we're going to do is we're going to think about this as an integration by parts. and we have to decide what's our f prime and what's our g. Now, we can't pick f prime as the natural log of x because what we want to do to get f is we anti-differentiate it. And if we could anti-differentiate natural log of x right away, we wouldn't be doing integration by parts, right? We don't know how to anti-differentiate natural log of x. So we're kind of forced to choose g of x to be the natural log of x. And f prime is 1, which at first doesn't look very helpful, although it turns out it is. And the reason why it's helpful is that if f prime is 1, then f is just going to be x. And if g is equal to the natural log of x, then g prime is going to be 1 over x. And so what happens is that the integral of the natural log of x is going to be f times g, so that's x natural log of x, minus the integral of f g prime, so that's x times 1 over x. And so that's x natural log of x minus the integral of 1, which is x natural log of x minus x plus c. Okay, and so this is an integral that comes up again and again and again to the point where I might add it to our list of integrals that we should know. So the integral of the natural log of x turns out to be x natural log of x minus x plus c. Okay, and again, that one's important enough, I may just add it to our list here. Okay. All right, so that's that. This trick, by the way, also works for evaluating the integral of the inverse sine, inverse tangent, okay, things like that, where you have this inverse trigonometric function. So anyways, it's a nice little trick there. So finally, let's look at the integral, I'm going to call it I, of, let's say, cosine of 3x e to the negative 4x dx. Really, we could do this with a's and b's if we want, but whatever, just cosine of 3x e to the negative 4x. And so what I want to do is I want to think of, I mean, this is a product, so it's natural to think of this as a integration by parts. And so let's think about what's our f prime and what's our g. And it turns out it doesn't actually matter all that much. What's our f prime and what's our g? So f prime, yeah, it doesn't matter. We'll say is cosine of 3x. G is e to the negative 4x. This makes f 1/3 sine of 3x because we're anti-differentiating cosine and we're differentiating e to the negative 4x. So g prime is negative 4 e to the negative 4x. Okay, so we anti-differentiated the trig function, differentiated the exponential function. So that means that our integral I is going to be equal to, so I is going to be equal to f times g. So that's 1/3 sine of 3x e to the negative 4x minus the integral of f times g prime. So that's minus a negative 3/4. Sorry, 4/3. So we have a, yeah, 4/3 integral of sine of 3x e to the negative 4x. Okay, and then how do we evaluate that integral? The integral of sine of 3x e to the negative 4x. Well, what we can do is integration by parts again. And so we'll leave this blank, like I said. So this will be 1/3 sine of 3x e to the negative 4x plus 4/3. So we'll leave this blank like we did before, is what I meant to say. And then we just have to evaluate this integral. And so if we have the integral of sine of 3x e to the negative 4x dx, we have to think about what's our f prime and what's our g. Now, before, what we did is we integrated the trigonometric function and differentiated the exponential. And so I want to do that again, because if we flip it, then what's going to happen is we're going to end up with I equals I and go from there, you know, and that's true, but not helpful. So I want to let f prime be the sine of 3x in this case. G is still e to the negative 4x. f, then if we anti-differentiate, will be -1/3 cosine of 3x. G prime is -4e to the -4x. And so this integral is going to be the integral of f times g, so that's -1/3 cosine of 3x times e to the -4x minus the integral of f times g prime. So that's minus minus 4/3. So these two multiply to give you positive 4/3, but we're still subtracting it. So -4/3 cosine of 3x e to the -4x dx. And that's -1/3 cosine of 3x e to the -4x minus 4/3 times I, where I was the integral that we were evaluating at the very beginning, right? This integral of cosine of 3x e to the -4x is the integral that we started with. And so what we can do then is we'll take our expression for this integral sine of 3x e to the -4x, we'll take this expression and plug it in, and then we'll have some equation in I that we can solve. So we get -1/3 cosine of 3x e to the -4x minus 4/3 I. And then if we distribute the 4/3 through, add the terms to both sides, we get that. So this will be, I'm just going to do this algebra all in one step. What could possibly go wrong? We'll get -16/9 that we're going to add to both sides. So we get 1 plus 16/9 times I. So that's 25/9 times I is equal to this right side without the I term. So that's 1/3 sine of 3x e to the -4x minus 4/9 cosine 3x e to the -4x. And so therefore so this implies that the integral that we're starting with was 9/25 times all this. And I need a plus c here. So that's 9/25 times 1/3 sine of 3x e to the -4x minus 4/9 cosine of 3x e to the -4x plus c. So I'm going to add one more line in so we can simplify our constants here. But that means that I was really equal to, let's see, 1/75 sine of 3x. No, is that right? No, of course that's not right. 3/25, sorry. 3/25 sine of 3x e to the -4x minus 4/25 cosine of 3x e to the -4x plus c. Okay, and so that's our integral there. I'm not going to put it in a box because there's too small there, but that's our integral. Okay, that's how we do that. So we had to do integration by parts. We did it twice, and we solved for I, and that was that. Okay, I'm going to leave it to you as an exercise to try and evaluate the integral of x cubed e to the 2x. Okay, and so what you want to do is you want to set up your integration by parts so that at each step the process gets similar. And of course you'll do integration by parts multiple times. Okay, so I'll leave this to you. Maybe we'll even do this one in class together. Okay, but I feel like that's a pretty decent overview so far of integration by parts.